and you're all going to fall asleep. And then afterwards, we're going to wake you up and get you to try some of our equipment and have a go yourselves, okay? So, when I finish talking, and I'm afraid you're going to have to sit through my talk first, when I finish talking, some of you will have a go to do some 3D designing, and some of you will perhaps even get your faces scanned, and you'll be able to see a virtual model of your head on the screen. So that's the sort of thing that we're going to do with you. So, first of all, I'm going to talk to you about the company, what we do, why what we do is important to you in the school context, why it will help you to learn. And then what I'm going to talk about is why 3D printing is going to become really, really important during your lifetimes. And you're going to see it in all sorts of different places. Yeah?
What is your company?
Sorry?
What is your company?
The company is called It Is 3D. That's our company. And so in the name of the company, there's a bit of a clue as to what we do. So, here are some of the benefits that you get from using 3D technologies. What we want you to end up with is creative skills. We want you to be able to start to think, what do I want to create, what do I want to design, and give you the tools to actually turn those ideas into physical models. So this is a science tool, and this sort of stuff works just as well with science as it does with design and technology and other subjects. So it'll give you the chance to learn some technical skills, but it works for the whole school, for every subject, and we'll show you a bit about that later. Soft skills for employment. Now that's probably something you won't have heard of before, but at some point you're going to finish school, and when you do that you're going to want a job, and you're going to want a good job, and you want a well-paid job. And what the idea is that with this equipment, you will, and the way you learn it, using it, you will have the skills that future employers are looking for you to bring with you. So they will say, okay, I've got a job here, I've got 100 people who want that job, but that person from the East London Science School, they've got all of the skills that I want, I'm going to take them. So that's what we're looking at. And we think motivation, we think you'll find it exciting. So, creative skills, you can see on the screen at the top, the young girl, she's using this equipment. And what we've got there is a virtual 3D world on the screen. And this is what? Any ideas? Yeah?
3D scanner?
No?
3D printer?
No?
Isn't that hologram?
No? It's a mouse. It's a computer mouse. But it's slightly different from your normal mouse. This is a 3D mouse. And that helps you to be able to move the cursor around anywhere on the screen and change the shapes of objects. What is really interesting about it, though, is it is hapticated. I'm going to guess that none of you have heard the word haptics before. Am I right or am I wrong? Any suggestions? Yeah?
You are right.
Yeah, right. Good. Haptics comes from the Greek word haptein, and what it means is touch. So what happens when you move the mouse, which moves the cursor, and it touches an object on the screen, so you've got the cursor coming along, it touches an object, you will feel it. That mouse will not be able to push the cursor through the object, so you will feel it as if it's a real object. We'll wait until you get a chance to try it, and then you'll see what I'm talking about. We also we want you to be creative. We want you to design. We want you to use this sort of product. We also want you to understand about scanning. So we'll show you that later. And the last word there is innovation. We want you to start to think what nobody else has thought before. And if you can do that, then you will be fantastic. That's what the world is looking for. People who can think differently. And I think you're in exactly the right school for that. So, technical engineering skills. There is a word STEM. That stands for science, technology, engineering, and maths. And that's used a lot in the industry about the sort of skills that companies want. I prefer the word STEAM, which is STEM plus an A for arts, where the art really means creativity. But if you put a C in, and you get STECM, that doesn't sound as good as STEAM. So that's the sort of thing that you're going to learn about. So, employability skills, the sort of things that employers want are being able to work as teams, but also being able to work as an individual, being able to do project work, being able to stand up, as I am here, and do a presentation. So in other words, you do a project and you present it to the rest of your class and your teachers. That's a great skill to have. And we've already talked about innovation and creativity. Now, this sort of stuff works in any subject. Now, a few of you have got quite a lot of samples sitting in front of you. And the point is that with this technology, you can make anything. So anything that has been designed as a 3D model on a computer, you can print it. And it doesn't matter what it looks like, it doesn't matter what its shape is, how big or small it might be, you can print it. So that's why it's a very powerful tool.
Sorry.
Now, I'm now going to just very quickly tell you where, oh, by the way, this is our 3D printer. And whilst I'm talking, you can see it printing. This is the material, this is the plastic that we're feeding through this tube to the tip. And it's being melted at the tip and put down in very fine layers. Yeah. So something that is designed there can be printed here, and then you can see, well, we've got a Dalek that we were printing at an event yesterday. There's a tall building that was printed very recently, and lots of other models. You'll get a chance to come around and have a look at them and have a feel of them later on. But that's the printer. So where does this technology come from? About 20 years ago, somebody had an idea for making a machine which allowed you to prototype. What that means is that if you're designing something, you can make a model before you went to production. And that's where this whole technology started. And it's been used in industry by big companies. So if you want to design an engineering part, if you're making a car or an aeroplane, if you're designing a building and want to make a model for people to see, if you're a jeweler and you want to make a part either for somebody to wear or as part of the prototyping process, that's how it's used. The problem for this coming to the general public or in schools was it was very expensive. There was very few materials that could be used. And do you know about patents? Do you know what a patent is? Yeah? Sorry? No, they're not shapes. Yeah? Yeah?
It's like a design, like triangle, triangle, square.
Not quite, no. Let's have a look at it.
It's a design that is a
Not quite. Let me ask that lad there.
Is it a series of objects that make up?
No. Okay.
Did you say pattern?
Patent.
Oh.
So perhaps you can't see it down here. P-A-T-E-N-T. Sorry, you misheard me. Anybody know what a patent is? If you're a designer and you've designed something new, let's say you've designed an iPhone, and you don't want other people to copy it, you take out what is called a patent, which means that what you've invented is protected, and for 20 years, nobody else can make it in exactly the same way. But what happened with this technology is that after 20 years, one of the patents ran out, and it was the patent that this machine is using. So it's melting plastic and making a 3D model. That patent ran out, and now other people can make the product. So when we started, the cheapest 3D printer in the world was about £15,000. And we brought a machine that was under £1,000. And that was because the patent had run out and we could make it a lot cheaper. Yes?
How much are they now?
There are quite a few now that are under £1,000. There are the cheapest ones are about £500, but they're not necessarily easy to use. So you've got to be careful as to what you use. So now what we're going to do is we're going to look at the way that 3D printing is going now and in the future, and this is what is going to make a difference to your lives when you left school, perhaps while you're at school. So it's used in engineering. This company, they wanted to make a mask for people going into fires so that they didn't have to breathe the dangerous fumes. And if they had used traditional means of prototyping it, of testing their design, it would have taken them several years to produce the model. They managed to do it in a year, and that's the final product that they made. You may have heard of a company called Samsonite, who make suitcases. They're probably the biggest suitcase company in the world. They use this technology for prototyping, for testing their ideas before they go into production. And I don't know if you can see this model down at the bottom. That photograph could have been on this slide, or it could have been on a medical slide. But this lady has got a prosthetic limb. She's got one leg which is lost, and so she's got an artificial limb. And this technology is really great for making prosthetics, making artificial limbs. Architecture. This is a model which has been 3D printed, so using machines like that, of the capital of Sweden, which is called, anybody know the capital of Sweden? Yeah?
I can't remember, but it's still O-S-L-O.
That's the capital of Norway. That's the next country to Sweden. You're very close, but it's not Oslo. It is in fact Stockholm. So this is a model, a 3D printed model of the centre of Stockholm. You can see there's a lot of water there. And here's the same model in a bit more detail. So if you are an architect and you've designed a new building and you want your customer to understand what you've designed for him, you will print a 3D model and you will show him, and he'll say, now I understand what you're talking about, because I can see what the building is going to look like, even though it's a small model. Fashion. Here are some examples of how 3D printing is used in fashion. And what is happening at the moment is that there are some fashion designers who are being really imaginative and just thinking, if I use this technology, I can make garments, I can make clothing, I can make accessories which have never been made before. So here we have a British designer called Catherine Wales, and she has designed this and this mask. And there are two things which are interesting about it. One is that nobody has ever designed clothes which are exactly the same as that. The second is that these are designed to perfectly fit the model. Now, when you go out shopping and you buy a dress or a pair of trousers or a shirt, you're buying something which is an approximate size. And there'll be thousands, hundreds of thousands or millions of people that will wear the same shirt, the same dress. And it'll fit you more or less, but it'll never be a perfect fit unless it is made for you personally. And the fantastic thing about 3D printing is you can make it personal for you. So you would go into a booth, you could have your complete body scanned so that your body exists as a virtual file, a 3D design file on a computer, and then somebody can make a 3D printed garment which absolutely fits you perfectly. So that's one of the great things about this, and it's going to change fashion. And here we have another 3D printed garment made by a Dutch designer called Pierre Hindsley. So those are just two examples. Some more in fashion, shoes. So here are some pretty crazy shoes that have been designed, and then designed in 3D on a computer, and then printed in 3D. So this is a journalist from the Daily Mail who's trying on some 3D printed shoes. And you can make some shoes which have never been designed or made before. I don't know if you can see this one clearly. This is a really crazy design for a shoe. I bet it would be really uncomfortable to wear. But actually that doesn't matter. At the moment, what is interesting is that people are experimenting, seeing what can they do with this. And as the materials improve, then maybe they'll be able to find a really soft, flexible material which makes that shoe really comfortable. We'll see. But these are things, all of these things that I'm showing you now were at the beginning. People are just trying it out to see what they can do with it, and there's a whole lot further that can be done. Now, there is a 3D printer which prints chocolate. Now, on the whole, when we go into schools and tell kids that there's a 3D chocolate printer, they say, boring, not interested in chocolate. And I can tell you feel exactly the same way. None of you like chocolate, do you? Oh, am I wrong? Okay. Well, obviously you're different from all the other children. Now, what happens here is this here, you can see the tip of a 3D chocolate printer. So again, you can, on your computer, you can design a special shape just for you, and then you can print that shape, and everyone can be different. Yes?
Would it actually be made of chocolate?
It would actually be made of chocolate.
What
You can eat it, absolutely. No, there are no chocolate parts here, I'm afraid, yes?
How much will it cost?
The machine, I'm afraid, costs £3,500. Hang on a sec, quiet please, I can't hear what you're saying. Say it again. Okay, fine. Now, I'll give you an example of what you can do. Let's say, quiet please. Come on, listen to me please. Let's say you're going to go along, you're going to hold a birthday party for your 16th birthday. And you're going to be inviting all your friends. And what you want to do is you want to give a special present. You're giving the present to your guests rather than the other way around. Hopefully they'll give you something as well. But you're going to give a special present to every one of your guests. And what you could do is, let's say you're very interested in cars. You could design a car on your computer, and you could put in writing on the top of that car the name of each guest. And each time you print a model, it would be a printed model in chocolate of a car with Joe, or Peter, or Anne, whatever it may be on top. Yes?
Where can I buy it?
Sorry?
Where can I buy it?
Where do you buy it? You go onto the website of Exeter University and look for chocolate printers. You still have to buy the chocolate first, and you've got to melt the chocolate in order to be able to make them off. Okay, moving on. Now, this is a very important part of your future. So, let's have a look at this one. Here, this is the model of a skull of somebody who had a very bad accident. And he lost part of his skull here. So what the surgeons were able to do is they were able to, using this technology, they were able to design a replacement for that part of his skull, which was exactly the right shape to fit in the hole. And then they printed that in titanium, which is a very hard metal, and a metal which can go in the human body without causing any problems. And as a result, when he had his operation to repair his skull, they were able to do it very quickly and easily, and mean that he could have a normal life in the future. I don't know if you can see this photograph down at the bottom here. This is somebody who was born with a deformed ear. And so what was done, a 3D printed ear was made, which was then painted to be exactly the right colour, and he had his deformed ear replaced with one that fitted and looked perfect. So he was very happy. Right. Let's have a quiet please, and then I can answer the questions. We'll start with that. Sorry? His problem was the shape of his ear out here. The hearing bit is inside, so it didn't affect his being able to hear. He could hear. Yes?
My friend, he has the same ear.
Does he? Well, you can tell him what you've seen, and you can tell him that in the future he will be able to have an ear which looks perfect. But I'm going to tell you something more about your friend in a moment.
Can you hear the 3D thing?
Well, it doesn't help you to hear, but all it does, it means it looks better. So people don't stare at you and say, oh, he's got a funny ear. Yeah.
But then scientists already found out that you can make an ear grow inside the mouth.
Yeah.
That's right, absolutely.
Well,
So
just took from that, be like mouth ear.
okay, I'm going to talk about that now. So, yes?
Do you know how they would take the arm off and put the arm back on?
Well, this is medical surgery, so I'm not an expert in that field, but I think that's very easy for a surgeon to do. But I can't give you the exact details. So let me now talk about ears on the backs of mice and other things. So let's just look at this photograph. This doesn't look like very much, but what that person is holding there in their hands is a piece of skin, and it is 3D printed skin. So, what you have in your body is millions and millions of cells. That's what your body is made up of. And in your body, some of those cells are what are called stem cells. And stem cells are very special because from a stem cell, you can make any other type of cell. So what they did there was they took somebody's stem cells and they printed a piece of skin, and that piece of skin is actually a piece of skin belonging to that person whose stem cells they used. The only difference is it's not attached to his body at the moment. Yes. Good point. I'll answer that. Right. So, what this means is that if that person, let's say that guy was went down for breakfast and was making himself a pot of tea, and somebody talked to him just as he was pouring the kettle out, and instead of pouring it into the cup, he poured it over his arm. What happens? Well, you get a burn, and you also get a huge blister. And when the blister heals, you're still left with a very nasty looking burn mark on your skin. So what happens? You need a graft, a skin graft. At the moment, a surgeon will go to the back of your leg, take a piece of skin off, and fit it here, which will be okay, but it won't be quite the same colour or the same texture. It will look different because it's from a different part of your body. With this, they can print a piece of skin, exactly the right shape, the right colour, and exactly the right size, and a very simple operation, and nobody will ever know that you have had a burn. Now that idea can be taken further, and you've mentioned you can make an artificial heart. Well, you can't really yet, but people are, in a number of universities are experimenting to try and do that. So they're working on printing human hearts, livers, kidneys, so that what will happen in a few years' time, just give me a moment, in a few years' time, you will be able, if you have, let's say you have a problem with your kidney and you need it replaced, you won't have to wait for a donor. All you will do is print your own kidney, and all that happens is the surgeon then prints a replacement kidney and puts it into your body. So your friend with the ear, or his, you may be able to actually print an ear using his stem cells, so it's his ear that is fitted. You want to ask a question?
So you can make a cyborg.
Well, that's actually a slightly different thing. A cyborg is somebody who is part human and part mechanical.
Is it that?
Well, that's not really a cyborg, because all you're doing is you're putting parts of his body back into his body, which has just been grown outside his body.
So if you just get that heart here, would that still beat?
Well, it wouldn't beat unless it was inside the body. So, yes, you could stimulate it with electrical signals so that it beat for a while, so that it was ready to go into his body, but you wouldn't just want the heart sitting there beating away by itself. There wouldn't be a point in it. Yes?
I am a cyborg.
You are a cyborg. Congratulations. Which bit of you is non-human?
Yeah.
So what have you got?
I have a mechanical arm and I have a pacemaker.
Okay, that's great. I'm also part cyborg because I broke my leg earlier this year, and so I've got a metal plate screwed into my leg. So I'll have to wait to see what happens when I go through a scanner at an airport to see whether I set it off or not. Yeah?
Can we see it?
No, you can't because it's inside. It's inside, fortunately. Just as yours is inside. But I'll tell you one other thing whilst we're on the medical field. We saw a video a couple of days ago, wasn't it, of a scientist in Bristol, and what he's done is he has produced a bionic hand. So this hand, at the moment, it's just pieces of black material, but when he attaches a couple of wires from his muscles in his arm, and he opens and closes his hand like this, exactly the same thing is happening to his bionic hand. So in the future, if somebody has an accident and they lose their hand, they'll be able to have a replacement hand which actually works. And it's not just a piece of wood or plastic stuck on the end of their arm. Yes?
Which year?
What, sorry?
Which year?
Which year what?
Which year would this stuff come out? 2045.
Any. Right, I'm going to move on from medicine. Yes? One more question.
the machine that you can make chocolate, you can make your hand. How many kind of machines like are there?
At the moment, there is one chocolate machine in the world, but other people will be making them. Hang on a second. The bionic hand, he used a machine like this to make the parts for that hand. So the point is that with a very simple, low-cost machine like this, you can make some fantastic stuff. One thing that we want to do in the future is make a machine which will not just make plastic parts here, but then you can also make chocolate out of it. So as soon as we have that, I'll talk to your headmaster and suggest to him that you might be interested. Yeah?
Like, could you like make anything?
You can't make anything. You could, but the thing is that the machines are limited as to what material they can use. So with this machine, we can print 3 types of material. One is a material called ABS. So on your car, the dashboard or the bumper, that might be made of ABS. It's a strong engineering plastic. I'll come back to it in a second. Secondly, what are we using today? This is ABS. So we're printing with ABS here. Some of the models there are made out of a material called PLA. PLA stands for polylactic acid, and polylactic acid is a biopolymer, which means it's made from natural parts. So our PLA is made from wood fibre. So if you make a part with ABS, it becomes a part of the, and you don't want to keep it, it becomes part of the plastic waste that we have in our world. If you print it with PLA and you don't like it, you put it in your garden, and after 6 months it'll have disappeared, it'll have biodegraded completely. So we rather like PLA. Hang on a sec, this young lady had a question.
Oh, what's it making now?
What is it making now?
What did we pick?
Yeah, Nefertiti.
We're making a bust of Nefertiti.
Do you know who Nefertiti is? She was an Egyptian queen, and we've got some statues that came through from about 3,000 years ago, and so we're making a copy of that statue. And the way that we were able to make a copy of that statue was by using a scanner like that to scan it, and then turn that scan into a 3D model, and you'll see it as it comes out now. You.
So you know the one that vanishes that?
Sorry?
You said you could put it out in the garden and it would vanish.
Yeah. It basically doesn't vanish, it just goes back to its original material. It becomes wood fibre or cellulose.
But say if you know you can say people are like making hands and like
Yep.
stuff like that. What happens if you use that material?
You probably wouldn't use that material for that purpose. But unless the material gets PLA, unless it gets very hot, and I don't know if you've ever seen a compost heap in the garden.
Yeah.
If you dig inside a compost heap, it gets really hot in there. And that's why the material then decomposes. Yeah. Yeah.
How long does it take to make the model?
So it depends on how much material you're melting to put down there. So this model is going to take, what, about 2 hours?
1.5.
1.5 hours. We've got other models over there. The space shuttle took, what, about 2 days altogether? And there are other parts there which just took 20 minutes or so. Yes.
Can we have a go at Pegasus sample?
Hang on, I was asking him about that. One moment. That's okay. What's the machine? It's printing. So it's taking this material, melting it, and putting it down layer by layer. Yeah, sorry, you asked a question? You had fun?
Can we have a go at
What you can do is we can show you how we set up a model for printing, and then you can see how it starts to work. Yes.
You had a chocolate machine.
There's only one in the world.
I haven't got one.
I want that.
We will have one.
We will in the future. We're going to design
In a
it.
few months' time, it will come back and we'll
Show you how to
test
print
on
a
here,
chocolate.
right?
What year? I want it.
Oh!
We'll come back to you. Yeah.
Are we going to use the 3D mouse?
You are going to use the 3D mouse. Okay, no more questions for a moment because I want to get on. So here, and the quicker I finish, the quicker you can start to play with the equipment. So this is a machine which is big enough to make a 3D building. And this is going to change, thank you, this is going to change the way that buildings are made, because you can make buildings very cheaply and very quickly. Food. You can make food through 3D printing. There are some food printers in the world. Hang on, let me finish. Quiet, please. That is a 3D printed whistle. And that's to keep you unruly lot under control. So, a bit of quiet for the moment, please. So, here you can see a model of a building that was made out of ice and sugar. That was 3D printed. Here you can see a burger. And this is a 3D printed bun. And at the bottom here, this is somebody's crazy idea about how in the future you might be able to 3D print any food that you want. So each of these containers will have a different type of food in, and so you might say, okay, what I want for dinner tonight is I want it to be the shape of Big Ben, I want it to be made of chocolate, mustard, and some cucumber. And you can program the machine, and that's what you'll get. So you'll be able to have your favourite food, which I'm sure is what I just described. Okay? Come on, let's carry on. Oh dear. That's, by the way, that's my 3D printed whistle. Anyway, keep us not quiet. Alright, 3D printing in space. NASA, which is the American organization which manages all their flights into the space, which took man to the moon, and which is responsible for the space shuttle and so on, they are spending a lot of money with American universities to produce 3D printers for space. Now, why would you want a 3D printer in space? I'm going to tell you. Now, you've had a lot of questions, so let me quickly finish. So, if you are, there is an international space station going around the Earth, and if something breaks up there, you have to then have a very expensive, and I'm talking about tens of millions of pounds, to take a part from Earth up to the space shuttle to repair it. If you've got a 3D printer in space, you can print the part whilst you're up there. And here is some people in free fall, and they're actually inside a plane rather than the space station with a 3D printer. But NASA have said next year there will be a 3D printer in space. And this one, which is really wacky, and it may take a very long time to happen, NASA are thinking, we want to get man to Mars. So, to carry everything that you might need to build somewhere to live and to work on Mars would be incredibly expensive. So, instead, the idea is you take a special 3D printer with you, and when you get there, you build everything you need from the materials you have on the surface of Mars. And that's what this idea is, and there is an American university, University of Texas, that is working on this project. It'll probably take them 10 or 20 years before they get it working, but get it working they will. All right, I'm going to take two questions and then move on. Yes?
If they use the resources of Apple Mars, why don't they just remain on red rock?
Because that might be fine for making bricks, but that's not going to be good for making everything. With a 3D printer, you can make things the right shape, the right sort of material for anything that you might need. Yes?